Welcome to Rest Assured lesson number 2, REST API. At the end of this lesson, you will be able to explain client-server architecture, discuss HTTP request and response, discuss REST API, explain base URL, explain REST API calls. Client-server architecture. What is client-server architecture? So as we discussed in lesson number 1 also, all the web APIs are basically based on client-server architecture. So in client-server architecture, multiple client machine request something from the server, and then server based on the request, responses, and the data transmission between server and clients happens through either in JSON or in XML based on the service type. Okay, so client server architecture is a computing model where server host deliver manages most of the resources. As we discussed, it could ask for resource, it could ask for certain elements or assets. So everything can be present on server based on the client request. The data is transferred from server to clients. This type of architecture has one or more client computers and connected to a central server over a network or internet connection. So there would be a central server, and in case there is a lot of traffic on that server, then it has a multiple server distributed over a network, right? And once client request based on certain parameters sent to the server, and server then replies back based on certain algorithm or the process implemented by developers to clients. Client server architecture is a distributed system architecture where workload of client server is separated. Clients are those who request services or resources. Servers are resource provider. The server host has several program at its end for sharing resources to clients whenever required. So we discuss in the last definition also. So we have multiple clients requesting multiple things from the servers, be it a resource, be it a data, be it a image file or an asset. All those requests are sent to the server, and then server, which is basically a resource provider, provides all those detail based on requirement. So server have different programs written by developers, and then based on the logic and the client request, server serves all those data, all the images or the assets or the resources to the clients. So client server architecture is a centralized resource system where server contains all the resources. Server is highly secure and scalable to respond to clients. So most of the time, it's actually a server is multiple clients requesting to the one central server. But sometime when there is a lot of traffic on the website or a lot of traffic on the web application, then what happens? We distribute our traffic to different small servers so that in case of lot of load, a load balancer can distribute traffic in multiple servers within the network. Client server architecture is service oriented architecture. That means client service will never be disrupted. Client and server can be on the same NIST system or maybe in a network. So it's a service oriented architecture. That means all the client services will never be interrupted. So no matter what happens, client services will always be up and running. Client and server can be on the same system or in a network also, and still they can run parallelly. So something like internet website are actually working within the network, or proxy based website actually works within a network, or VPN based website actually work within the network. So the client and server can be within the network or can be outside the network based on the application type. So this image actually represents a good client server architecture. You can see there are multiple clients here: client 1, client 2, client 3, client 4, and a lot of requests are being made to the server, and then server is parallelly responding to all those requests. So even when there are parallel requests from multiple clients, server would be able to handle those. And in case there is a lot of load on the server, through load balancer, it would be distributed between small subservers, and then they will respond to those requests. HTTP protocol between client and server. So as you can see, this is the client, which is our web browser, Chrome or Firefox. It sends a HTTP request message to the HTTP server, which is a web server, and then web server, based on certain parameters or the program logic, responds with a HTTP response message. Now we will go in detail about the HTTP request message and the HTTP response message. Other part, like different parts of HTTP response message, similarly different parts of HTTP request message in deep in the upcoming slides. Let's understand the basic concept of HTTP protocol. So HTTP protocol is mean for two systems to interact. So here client and server are actually interacting through HTTP protocol. It's a protocol to ask the required details from the server. It could be any form in formatted data. The most commonly used formats are XML and JSON, as we discussed in the last lesson, that mostly for the SOAP services we use XML, and for the REST services we use JSON. Now the server responds by sending a response data in formatted data again, and it could also be XML or JSON. So basically this transformation happens through a transformation medium, and this medium could be XML or JSON or sometime in TXT also. So based on the service, the web service type, the data is transferred between server and client, right? So a web browser, which is our client, sends a request in XML or a JSON to the HTTP server, and then server responds through an HTTP communication protocol. HTTP request and response. As I said before, like we will go deep about HTTP request and HTTP request response. So first of all, let's talk about HTTP request. So it's HTTP request is a package of information that one computer sends to another computer. The one computer here is basically our client machine computer, which is a web browser. Web browser has certain properties. Our computer, which is hosting a web browser, have certain properties like IP address and so on. And now the another computer is our server, which is also a kind of a computer, like high power computer, but it is also a computer to communicate something. HTTP request is a packet of binary data transmitted by the client to the server to its core and contain different parts. So this is one example of HTTP request. This HTTP www.example.com is actually a URL which is called a universal resource locator. This 80 is a port, and /index.html is the resource which we are requesting. So let's go in detail. Request line specify the method token get put followed by the request URL and then the HTTP protocol used. So here you can see HTTPS. This is our HTTP protocol. For secure protocol, it would be S, and for non-secure protocol, it could be HTTP. Play.google.com is actually our host or URL. This URL means uniform resource locator. /log format is equal to JSON and has fast is equal to true. So /log is our resource, and then format is equal to JSON and has fast is equal to true are our parameters. We'll talk about detail in the next slide. Request method is equal to post. This is where we define what kind of operation we are trying to perform here. So basically we map it to the database operations. So for creating something in database, we have post. This is general term, but based on the implementation of post can differ, but generally on the database side, post is equivalent to create something or insert a statement. Status code, so this actually tells us whether the response is correct or not. So status code means when it is 200 means everything is good. The server is working fine and services on the server are working fine and giving us the correct results. Two XX messages are actually equivalent to correct results, and 5XX messages are equivalent to some server side errors. We'll go in deep in the upcoming slides. Remote address, this is your server address, like the client actually requesting something from server. So this is the remote address, which means this is equal to play.google.com. So this is the domain or the uniform resource locator, and this is the server IP. Reference policy origin, it means that the referral is the origin, which is play.google.com. So as we saw, request URL contains two values, format is equal to JSON and has fast is equal to true. These are parameters. So this is resource URL, play.com/log, and then these are parameter. That means from the play.google.logs, give me the data in JSON format and has fast flag is true, right? So this is actually a resource URL and these are parameters. And other things we already discussed in the previous slides. Parts of HTTP request header. So an HTTP request carries 0 or more request header. Anything that follows request line until before request body is actually a request header. Everything is in header is request section. Requests are used to pass new information about the request to the server. So now when client is sending some request to the server, how can a server know what about the more detail about the request? So only so when some clients are sending requests to the server needs to know that it is a valid request, it is coming from a valid IP, it is actually giving me the correct instruction to transform data. So let's say if the data transmission is possible in JSON only, it should not send XML data, and so on. So this is where all the information is sent from client to server in terms of request header. So using these request header, servers knows what action I need to perform and how to transfer the data from server to client and so on. So here you can see request headers have different fields. Authority play.google.com, it means if it is not coming from play.google.com, then just end this request, do not send the correct data to the client. Method is equal to post. If the method is not correct, then again send an error that your method type is not correct. Path is equal to this. Again, based on the path, the data is transferred from server to client. If this path is wrong, it will send a 404 data not found or file not found error. Schema is equal to HTTPS. It tells the server that whether the data is sent in encrypted format or not. Accept all, so it is not an issue. Accept encoding gzip. So this is basically to when the data is transferred from server to the client, how do you want to compress the data or not? So this is gzip is actually useful in compressing the data. Accept language, what kind of language we are accepting here. So here Britain and US. Content length, what is the content length which is being sent. Content type, this is important. So here application form URL encoded mean we are sending a data in form, and the cat set is UTF-80. So based on the content type, the server sends the data in either in this format or the which is the possible format on the server. Origin, this is basically if the origin is not correct or origin is something different, the server could have some validation on origin and could fail the request. Similarly for referral also, so which website is, so origin is basically originated request URL and referral is basically if it is coming from some referral website. Fetch desk empty, these are security related flags. CORS means cross origin request. Fetch site, same site means the website should be the same. origin, like google.com should be there for all the request, user agent about the user info. Here we are sending the data from this Chrome 80.3987. Client side data, so this is basically cookie of particular client. So this is unique for every client. So this is based on this cookie. Actually, if there are some same type of cookie is coming from this request, which is not from the same IP, so server can ban the request and give the errors to the client. Request body. So we talked about the request headers. Now request body, in case we are trying to insert something or we are trying to update something in database. So we are trying to use post method or put method, or sometimes in delete method also. We need to know what to insert in database or what to update in database or what to delete in database. In those scenarios, we need request payload, which will tell us that for creating a resource, the IDs would be this, something field with value would be anything, and IDs then for one it should be this, for ID 2 it should be this, and so on. So it is a part of HTTP request where additional content can be sent to the server. Here in request payload also we specify the transmission medium, like we are sending a data in JSON or you're sending a data in XML. So this was about HTTP request. Now let's talk about HTTP response. So HTTP response is a package sent by server to the client. So earlier in HTTP request, some data is transferred from client to the server. Here the reverse is happening. Some data is being transferred from server to client in response to an earlier request initiated by client. So HTTP response holds the information requested by client, and the response is done in a structured manner based on the content type provided by client and supported by server. So HTTP response structure, this is what it looked like. So here you can see a stated line consists three parts: HTTP protocol version, status code, and reason phrase. So here you can see status line is, it is showing us that it is an HTTP response, which is HTTP version 1.1. 200 OK means the response is correctly received. Response status code 200 OK means the response is correctly received and server is able to process your request correctly. Server information is distributed here. It should not be shown for security reason, but most of the website do so, which is a security loophole. We should not show any unnecessary information in response headers. So here it is showing us open resty date, which is the current date, when the request to response was sent. Content type, here you are giving us the, we are actually, response is providing information that the transmission medium is JSON. Content length, the length of the content. Connection close, so close the connection once the response is received. Cache key, again this is based on, so based on cache ID and the location. Access control allow origin, if this is again if we need to allow or allow request and response from origin only, so this is useful. Credential, allow credential to show, and then allow methods. So for this particular API only get and post are allowed. Response headers. So after the status line, headers are displayed just like request header. Response also carries zero or more information about header lines. However, it is very unusual to have zero headers in response. Lines just after status line or before the response body are response header. So when we send request to the server, the data, the informational data is sent in headers. Similarly, when server send to something to clients, informational data is actually present in headers. So as you can see, alt we see these cache control, content encoding, content length, content type, all the transmission related information, and date is basically response headers. Response body, just like request body, which holds the payloads, response body actually shows the data which is requested by client. So in our example, when we say city Hyderabad was required for weather data, look at the response here. So basically it gave us the information of the user which is residing in Hyderabad, right? His name is John Doe, and email is johndoe.example.com, designation is this, GitHub ID is this, about me is this. REST API. API is an application interface. It is a set of rules that allows programs to talk to each other. Developers build an API on the server and allows client to speak to it. So as we discussed in client server architecture, there are some programs written on the server. These programs are actually written in APIs, and based on the request made by the client, server process those requests and send the corresponding data based on the programming API developed by the developer. REST defines how the API looks. It stands for representational state transfer. It is a set of rules that developers follow when they create their API. One of these rules is states user to get piece of data called resource when it is linked to a specific URL. We discuss about REST in the lesson 1 also, and we discuss the principles and the rules of REST also, like rules of caching, rules for statelessness, and so on. So this is where these rules actually defines the structure for the API, and developers then create the API by following these rules. Each URL is called a request, while data is sent back is called the response. We discussed that in the previous slides about HTTP request and HTTP response. Anatomy of a request. So let's discuss all the things related to the request. So first thing is endpoint. So endpoint is the URL of the request. It follows structure like www.example.com or www.amazon.com or www.google.com. The root endpoint is the starting point of the API. The root endpoint of GitHub API is this api.github.com, while the root endpoint of Twitter API is api.twitter.com. The method defines or determines the resource of the request. User can access the path just like linking to path to website. For example, to find a list of all mobile phones on Amazon website, we have to navigate to amazon.in/mobile phone, where amazon.in is the root endpoint and /mobile phone is a method. Similarly, in our case, play.google.com is an endpoint and /log was our method. Headers, REST headers are a central part of the API request and response. They serve the metadata or the informational data connected with the API request and response. The headers may carry information for request and response body, request authorization, caching, cookies, security flags, cross-scripting flags, and sometimes data related to the client remote machine, client IP or client informational data. Query parameters gives the option to modify the request with key value pairs. They begin with question mark, right? So this also help us or help server to send data by filtering, right? So sometimes when clients request something from server, and the data is so large in the response, so to filter it we use these parameters, just like we used in parameter in the play.google.com, where we said give us all the logs where format is equal to JSON, right? Here the example is amazon.in/gp/help customer /display.html and node id is equal to this and ref is equal to nav/cs help. Base URL. URI stands for Uniform Resource Identifier. It is a string of characters that unambiguously identifies a particular resource. So we have a long resource. So to identify every endpoint uniquely, we use uniform resource identifiers. REST API use URIs to address resources. Endpoint. Let's understand endpoint first. So the whole API, we call it endpoint, but endpoint has certain different parts, like base URI is one part, resources is the other part, and the parameter is the last part. So in simple word, base URI is nothing but the host name or the domain name, right? So here you can see in the example HTTPS, which is a HTTPS mechanism, if support is secure or not, and then www.google.com/search/source is equal to HP and EI is equal to this. Q is equal to Bangalore, weather is equal to Q is equal to Bangalore plus weather, and OQ is equal to Bangalore plus weather. So let's understand everything in detail. So base URL here is https://www.google.com, right? And resource here is actually search, and the parameters are different present here, like source, EI, Q, and OQ. So all these are parameters. So combining all those, we create a endpoint, or we call it an endpoint. So example of for endpoint, as you can see the below image. So here you can see google.com/search, so equal to HP. As we discussed in the last slide, we search something like that, we find something like this, right? So here in the search, Bangalore weather, which we provided in query, Q is equal to Bangalore weather, right? And we got this image with these kind of details. So this is what an endpoint look like. Rules for URI. Rule number 1, a trailing forward slash should not be included in URI. So basically, if we have, so let's say api.com, api.canvas.com. Instead of this, if we have api/.canvas.com, it would be a wrong URI. So in case here the URI is api.com, api.canvas.com, which is a correct one. So REST API should not take a trailing slash, or should not add them in the links, and they provide to clients also. Many web components and the frameworks will treat the following two URI equally. So here you can see slash here at the end does not mean anything. Even if you don't provide this, it would be the same. The result would be the same. And in case of API slash dot, it is the wrong one. Slash slaves slash or slash slaves is equivalent. Forward slash operator must be used to indicate a hierarchical relationship, right? So if you're using forward slash, then it should have certain resource after that. It should not end with the forward slash, like rule number 1. So forward slash attribute is used in the URI indicate and hierarchy relationship between resources. Here you can see slash shapes slash polygon slash quadrilateral slash squares. So here it is actually defining a relationship. Rule 3, hyphen should be used to improve readability of URI. So to make URI make easy for people to scan and interpret, especially for the long keywords, the hyphen character is used to enhance the readability of names. As you can see here, api.example.com/blogs/guy -levin post. This is my first post. You see a lot of these in blog post, right? This is why. Underscore should not be used in URIs. So have you seen any website where underscore is used in the URI, right? Because this is the rule number 4. Text to your application, browser, etc. usually underline URIs to provide visual hint they are clickable. Lowercase letters should be preferred in the URI paths. So as you can see, mostly on the website, you see all those letters, either domain name or the pass or the resources, everything is in small letters. So this is again a rule. That's why you see all these endpoints on the websites in small letters. Lower letters are accepted in URI pass since capital letters sometimes cause problem. RFC 3986 define URI as a case sensitive except for schema and host components. So for example, api.example.com slash my folder my doc is the correct one. HTTP API capital.example.com is not a correct one. Similar, the last one where my folder is in capital is also a not correct way to represent in URI. Rule number 6, file extension should not be included in URI. So like .png, .pdf, all these extensions should not be part of the URI. A resource API should not contain artificial file extension in URI to indicate message entity body format. Instead, it should rely on media type, like content type is equal to text or JSON or file, right? All these things should be relied on media type. So as communicated through content type header to determine how to process the body content. REST API calls. So what is REST API call? So a RESTful API is an application program interface, right? We discussed about API. It uses different requests to get, put, or delete, or post data. REST technology is usually preferred over more robust, simple object access protocol technology because REST uses less bandwidth, because REST is lightweighted, as we discussed in lesson number 1. REST is powerful, faster, and that's why people or the application these days prefer to use REST, making it more suitable for efficient internal usage. REST API calls, let's discuss one by one in detail. Get, this method is actually equivalent to select statement in database. So used to retrieve resource representation. In this pass, get returns a description either in XML for SOAP or JSON in case of REST API, and an HTTP response code 200 OK mostly, sometimes 201 created for creating something. It mostly often returns 404 if the resource is not found, or 400 if the request is not properly sent to the server. Post, this method is often utilized to create new resources. On successful creation, HTTP returns 201 as we discussed earlier also. It is equivalent to insert statement in database, returns a location header with a link to the newly created resource. So once we create something, usually in body data, we get the resource ID or resource location. Put, this method is equivalent to the update statement in database. This method most often utilized for update capabilities. Put is used to a known resource URI with the request body containing the primary resource newly updated representation. Let's say when we have created the contact using post, then we need to update that contact, then we use put, and with the ID, let's say ID is equal to 1, we want to change the name is equal to Chandan to name is equal to something else. So this is where we use put. Alternatively, use post to create new, and then on successful update returns OK. So based on the implementation, post can also act as a put one, but generally the rule wise it suggests that we should use put when we try to update something. If we are using put for creating, then HTTP returns 201 on successful creation also. So put can be used to, so post is actually a master, and then put can do this thing, like put can be used to create some. So let's say we have a master data, and this data there is a category. Now to update something in category, let's say we want to create a category under a master data. So we create a master data using a post call, and then to add a category we update the master data while creating a category using a put call. So put call can be also used as a creation activity, but then it should be part of the larger post call. Delete, this method is pretty easy to understand. Used to delete the resource identified by the URI. Let's say once we created the contact, we updated the contact. Now to delete the contact, we will send a delete request with ID equal to, let's say, 1, and it should be deleted. And then we get the response as 200 with a response body as it like no content found or data is successfully deleted. If you have any doubts, you can reach out to us. Let's summarize. Client-server architecture is a computing model where the server host delivers and manages most of the resources and services to be consumed by the client. An HTTP communication protocol is a mean for two systems to interact. HTTP request is a packet of binary data transmitted by the client to the server to its core, and it contains different parts. HTTP response holds information requested by the client, and the response is done in a structured manner. API is an application programming interface. REST defines how API looks and works. URI stands for Uniform Resource Identifiers. An endpoint is a combination of base URI, resources, and parameters. REST API uses HTTP request to get, put, post, and delete data. Thank you for taking this lesson.